Okay, 8.7 is all about applications of right triangle trigonometry. So in order to understand the applications of right triangle trigonometry and to use sine, cosine, and tangent, we have to understand these two phrases here: angle of elevation versus the angle of depression. Okay, so we're going to draw a picture together, right? All you artists out there, you should be so happy right now. All right, so we're going to draw a picture. Okay, this is going to be a cliff. Woo! And then there's a canyon down here. Okay? Okay? This is a cliff. And then you are going to be standing on the cliff. Okay? This is you. Okay, that'd be terrible. Okay, now, down here at the bottom of the canyon, there's a rock. See the rock? There's the rock right there. Okay? And then flying high above you is a bird. Okay? See, there's the California con right there. Okay, there's the bird. Okay? So now we have to understand a couple of things here. From where you're standing at eye level, where's the horizon? Everywhere. Everywhere. The horizon is everywhere? Okay. Yeah, the horizon line for us, this is the horizon line. The line that is parallel to the ground, that is straight out. This is the horizon, right? Okay. The horizon is, for all intents and purposes, for what we're going to do, the horizon is going to be straight out, sort of eye level from where we're standing. Is that fair enough? Sure. Okay, now, from the horizon's important because that's where we measure angles from. Okay? So let's start with elevation. If you look up to the bird, okay, then here's the bird right here. The space that you've created here, this right here, is the angle of elevation. So it is measured from the horizon line all the way up. That's your angle of elevation. Good enough? Great question. What does the rock have to do with it? Let's say you're looking at the rock. Okay, oh, look at that rock down there. No. Okay, so the angle of depression would be this angle here, measured from the horizon down. Okay, this is your angle. Okay, you think about that. So what I don't want you to do, is to think that angle of elevation is like this space over here, or think that the angle of depression is this space over here. That's not what that is. Okay. So you have to understand what we're talking about by angle of elevation and angle of depression. Here's what I want you to do. I want you to listen right now, okay? Okay, everybody listen. Are you listening? Okay, I'm gonna read a little story to you. Here you have to listen, okay? It says this. It says, when the sun's angle of elevation is 28 degrees, a building casts a shadow of 45 meters. How high is the building? Okay, I'll read it again to you. When the sun's angle of elevation, which is the amount the sun is above the horizon, is 28 degrees, a building casts a shadow of 45 meters. The question is, how high is the building? So what we have to do is we need to draw a picture that represents the information in the story. So we have a building. Let's give ourselves a building. There's my building. Okay? The sun's angle of elevation, okay, is what? 28 degrees. The sun is above the building. There's the sun. Woohoo! Up there. Okay? The angle of elevation that it makes from the horizon is what? 28 degrees. So that means from the horizon up to there is 28 degrees. And it says that it casts a shadow, which is the shadow here. And the shadow is how long? 45 meters. The shadow is 45 meters. Question was, how high is the building? H. So for all sake and intents and purposes here, we have a very, 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 very basic right triangle, don't we, everybody? this is the right triangle that we have. This is 28 degrees. This is 45. This is a right angle because we're assuming the building is perpendicular to the ground. And then that's H. So, from my angle, everybody, what side is the opposite side? H, very good. What side is the adjacent side in my right triangle? Okay. And what side is the hypotenuse? Kind of like that one right there, crossing the right angle. Which one are we interested in? The opposite side, the adjacent side, or the hypotenuse? Which one do we want? We want the opposite side. We want the height of the building, right? So which trig function are we going to use? Remember, SOHCAHTOA, right? Okay, so which one deals with, what do we have? We have opposite and we have adjacent. Opposite and adjacent. Opposite and adjacent. Ooh, I'm thinking that we're going to use tangent. Because we have the opposite and we have the adjacent. Maybe it's a little easier if I do this so you can see. Okay? It's either sine, cosine, or tangent. We're going to use tangent because we have the opposite to the adjacent. So therefore, we're going to say this. The tangent of what angle do we have, everybody? 28 degrees has to be the ratio of H to 45. Opposite to adjacent. So we're going to then multiply. H is approximately, or I should just say equals for now, H is equal to 45 times the tangent of 28 degrees. So we go to our calculators. And we plug in 45 tangent 28. Therefore, H is approximately 23.927. H is approximately 23.927.